Imagine you're sitting at your desk at work. You open your browser, type mail into the address bar, and your company's internal email system loads. No .com, no full domain name, just the word mail. It works. You've done it 100 times. Now you go home. You open your laptop. You type mail into the same browser. Nothing. A connection error. The page doesn't exist. Same name, same browser, different network. Completely different outcome. You might have experienced something like this before and chalked it up to, oh, that only works on the work network. And that's true, but it's worth asking why it's true. What is it about the work network that makes mail resolvable, and about your home network that makes it meaningless? The name didn't change. Your browser didn't change. So what changed? The answer is scope. Every name exists within a scope, a boundary that defines the context in which that name is valid and resolvable. Step outside that scope, and the name might mean something completely different, or it might mean nothing at all. This idea of scope is one of the foundational properties of any naming system, and it shows up everywhere in networking, sometimes in ways you recognize, often in ways you don't. Understanding it changes how you think about DNS, about private networks, about cloud infrastructure, and about why certain things work in certain places and not others. Let's start by making the concept precise, because scope is one of those words that's easy to use loosely. In a naming system, the scope of a name is the set of contexts, typically the set of locations or systems from which that name can be meaningfully resolved. It defines the boundary of the name's visibility. A name with global scope can be resolved from anywhere. Someone in São Paulo, someone in Seoul, someone in Stockholm, they all ask the same question and they all get the same answer, or at least an answer that leads them to the same resource. Wikipedia.org is a globally scoped name. It's registered in public DNS, it's propagated worldwide, and any resolver on the planet can find it. A name with local scope can only be resolved from within a particular environment. It might be a private network, a specific organization, a single machine, or even just a particular application. Outside that environment, the name either resolves to something different, something that makes sense locally but isn't the same resource, or it doesn't resolve at all. Mail, just the bare word, is a locally scoped name. It only means something inside a network that's been explicitly configured to give it meaning. In your office network, someone set up a system that says when anyone on this network asks for mail, send them here. Outside that network, no such configuration exists, so the name goes nowhere. Neither of these is inherently better or worse. They serve completely different purposes. Global scope is what makes the public internet navigable. Local scope is what makes private networks manageable, secure, and self-contained. The sophistication is in understanding which one applies, when, and how the system decides. Let's look at global scope first, because you're already familiar with it, even if you've never thought about it in these terms. Public DNS, the system we walked through in the last video, is fundamentally a globally scoped naming system. When you register yourcompany.com, you're claiming a name in a shared global namespace. You're saying, this name, yourcompany.com, belongs to me, and anyone anywhere in the world should be able to resolve it and reach my servers. The hierarchy we discussed, root, TLD, authoritative name server, is what enforces this global scope, because every resolver in the world starts at the root, and the root knows about every TLD, and every TLD knows who owns every second-level domain within it. Any name registered in public DNS is reachable from any resolver on the planet. Global scope comes with a price, though, and that price is uniqueness. In a globally scoped namespace, every name has to be unique. You cannot have two different things both called apple.com. The whole point of global scope is that the name resolves to the same answer everywhere, so there can only be one answer, which means only one owner, which means only one thing can hold any given name at any given time. This is why domain names cost money and require registration. It's not really about paying for the name. It's about paying for the enforcement of global uniqueness, for your exclusive right to define what your company.com resolves to everywhere in the world. And uniqueness at global scale is a managed scarcity. Someone has to be in charge of it. For com, That's an organization called VeriSign. For org, it's the Public Interest Registry. For country code TLDs like UK or JP, it's national registry organizations. The global scope of public DNS is real, but it's maintained by a specific chain of authority that traces back to ICANN, the Internet Corporation for Assigned Names and Numbers, which coordinates the root zone at the very top. Take that chain of authority away, and you don't have global scope anymore. You have chaos because different parts of the world would start giving different answers for the same names, and the global namespace would fragment. Global scope is powerful. It's also not free. Now let's look at local scope, and this is where things get genuinely interesting. Every organization with an internal network, a company, a university, a government agency, faces a naming problem. They have internal servers, internal services, internal resources, a file server, a mail server, a payroll system, an internal wiki, and all of those things need names that people inside the organization can use to find them. You could put all of those names in public DNS. Register mail.yourcompany.com and files.yourcompany.com and wiki.yourcompany.com. Point them all at internal IP addresses, and in principle, anyone with your DNS records could see the names of your internal systems. But there are reasons you might not want that. You might not want the outside world to know the internal structure of your network. Your internal servers probably use private IP address ranges, addresses that don't exist on the public internet at all. 192.168.x or 10.x.x. These addresses only mean something inside your private network. Putting them in public DNS would be pointless at best and a security disclosure at worst. So instead, organizations set up their own internal DNS infrastructure, their own private name servers that hold records for their internal resources and that are only accessible from within the network. Inside the company, your device's DNS resolver is configured to send queries to the internal name server first. When you ask for mail or mail.corp.yourcompany.internal, or whatever naming convention the organization uses, the internal name server has the answer. It knows the private IP address. It returns it. You connect. Everything works. From outside the network, nobody's resolver is pointed at the internal name server. The name either doesn't exist in public DNS at all, or it might exist in public DNS with a different address, one that points to a public-facing service rather than the internal one. This is local scope in practice. The internal namespace is invisible from outside. The names only resolve and only mean anything from within the scope of the private network. Now here's where it gets subtle. How does your device know which resolver to ask? How does it know that mail should go to the internal name server rather than to a public recursive resolver? The answer is resolver configuration, and it happens at the network level, usually transparently. When you connect your laptop to the office network, whether physically, via Ethernet, or wirelessly, the network hands your device a set of configuration parameters through a protocol called DHCP. Among those parameters is the address of the DNS resolver you should use. On the office network, that address points to the internal name server. At home, your router hands you the address of your ISP's resolver, or whatever public resolver you've configured, so your device doesn't decide which namespace it's in. The network it's connected to tells it where to look, and where you look determines what you find. This is also why VPNs work the way they do. When you connect to a corporate VPN from home, one of the things the VPN connection does, often transparently, is change your DNS resolver configuration. Now your queries go to the corporate internal name server through the encrypted tunnel, even though you're sitting at home. Suddenly, mail resolves again, because your resolver is now inside the right scope. The name didn't change, the network configuration changed, and with it, your position within the namespace. Now let's talk about a specific technique that takes this idea of scope to a more sophisticated level: split horizon DNS, also called split brain DNS. The name sounds complicated, but the concept is elegant. Here's the situation it solves. You have a service, Let's call it portal.yourcompany.com. This service is accessible both from inside your network and from the public internet. But the experience should be different depending on where you're coming from. From inside the network, portal.yourcompany.com should resolve to an internal IP address, something on the private network. It takes you directly to the server without going out through the internet and back in again. It's fast. It stays inside the network perimeter. From outside the network, portal.yourcompany.com should resolve to a public IP address, the external interface, the publicly reachable endpoint, probably behind a firewall and a load balancer. Same name, two different answers. The answer depends on where the question is coming from. This is split horizon DNS. You maintain two separate DNS zones for the same domain name, one internal, one external, and you serve different answers depending on which resolver is asking. Inside the network, the internal name server handles queries for yourcompany.com and returns internal IP addresses. Outside the network, public DNS handles queries for yourcompany.com and returns public IP addresses. The person using the service doesn't need to know any of this. They type portal.yourcompany.com. At work, they reach the internal version. At home, they reach the public version. Same name, appropriate answer for their context every time. Split horizon is widely used. Cloud providers use it extensively. AWS, Google Cloud, and Azure all use split horizon techniques so that services within their networks resolve to internal addresses and communicate efficiently, while the same service names resolve to public endpoints for external clients. Large enterprises use it to route internal traffic efficiently. Content delivery networks use variants of it to direct users to geographically appropriate servers. It is, in essence, scope made operational, a formal mechanism for serving different truths to different contexts, based on where the question is coming from. It's also worth recognizing that scope isn't unique to DNS. It's a property of naming systems in general, and you encounter it in many different forms. Think about host names on a single machine. Your computer has a name, localhost, that refers to itself. If you make a network request to localhost, your operating system intercepts it and routes it back to the same machine without ever putting a packet on the network. Localhost is a name, but its scope is a single machine. It means nothing outside of that machine. Nobody else on the network can reach you by typing localhost. They just reach themselves. Think about how processes communicate on a single computer, through failmines that act as addresses, through process IDs, through named pipes. All names, all locally scoped to that machine. Think about container orchestration systems like Kubernetes, where each container can refer to other services by short names, just database or cache, within the same application namespace. Those names are meaningless outside that namespace. Inside it, they're how everything finds everything else. Think about how your home network probably has a rotor that assigns names to local devices. My laptop, smart TV, printer. Those names work within your home network, resolved by your rotor's built-in DNS. They don't exist anywhere else. In every case, the pattern is the same. A name exists within a scope. Within that scope, it's resolved consistently. Outside that scope, it's invisible, or it means something else entirely. Now you might be wondering, isn't this confusing? Doesn't it break things if the same name means different things in different places? It can, and when it does, it's a real problem. If your internal naming is poorly designed, if you use names that collide with public DNS entries, for instance, you can end up with very confusing situations where things work in some contexts and fail mysteriously in others. We'll see examples of this kind of thing when we get to naming consistency later in the series. But the core idea that names should be scoped is not a flaw. It's a feature, and a necessary one. Consider the alternative, a world where all names are global, all names are public, and every single device and service on every private network has to have a globally unique public name. The registration and coordination overhead would be enormous. Private networks would have to expose their internal structure. Every internal service, every development environment, every test system would need to carve out globally unique identity. That would be unmanageable. More importantly, It would break the fundamental purpose of private networks, which is that what's inside stays inside. Scope is what allows global uniqueness to coexist with local autonomy. The public internet has its globally unique namespace, carefully administered, and within that global space, every organization carves out its own private namespace, under its own control, subject to its own rules. The two coexist because the scope of each is respected. Your organization's internal name mail doesn't conflict with anyone else's internal name mail, not because they're different names, but because they exist in completely separate, non-overlapping scopes. They never meet. They never need to be reconciled. Scope is what makes naming tractable at the scale of the real world. And this also connects back to something from the last video. The hierarchy of DNS itself encodes a kind of scope. When a company registers yourcompany.com, they gain authority over that portion of the namespace. They can create any subnames they want within it. mail.yourcompany.com, files.yourcompany.com, without asking anyone's permission. Their authority, their scope, is everything within their registered domain. The TLD operator controls everything within com. ICANN coordinates everything at the root level. Each level of the hierarchy is a scope of authority, nested within the scope above it. You have full autonomy within your scope, and your scope exists within the constraints of the scope above you. It's a beautifully recursive structure, and it's why the Internet's naming system can be simultaneously globally coordinated and locally autonomous, because the scope at each level is clearly defined, clearly bounded, and clearly delegated.